Hi, this is Shannon Seaver, and this is Venn diagrams and set operations with 3 sets, part 2. So here we have a 3-set Venn diagram, and we want to construct the Venn diagram based on the items that we have on the left. We know what the universal set is. It's A through L. A is A, D, E, G, H, I, J, and so on. So the biggest hint I can give you on this is to work from the inside out. So in order to do that, let's look at where A, B, and C have things in common. Let's just list those. So looking across, A is not common for all 3 of them, and neither is B. It looks like C is not in common for all of them. D is not either, but notice that E is. So I'm going to list E here. G, once again, is not, but H is. And those are the only 2 that are in both, on all 3. So I'm going to list E and H here in the very middle of the Venn diagram. We want to do the same thing with A union B. So before I do that, I'm going to erase my markings here. A union B, what do they have in common? Well, A, B, C, D, but none of those are in common, but they do have an E, a G, and H, both in common. We've already listed E and H here. I'm going to label these sets. We've already listed it here, so the only other one that we have left to list is G, so I will put that right there. But A intersect B is E, G, and H. Now let's do the same thing for A intersect C. I'm going to erase my markings. A intersect C. Well, they both have an A. They both have an E, and they both have an H. So A intersect C is going to be in this section. We already have E and H written here, so the last one we have left to write is A. B intersect C. First, let's erase this and list what is in common in those 2. So it looks like the only things they have in common are E and H. So I'll write that here. Notice that we already have E and H listed, so I don't have anything in addition that I can list in this one. Okay, so what is in set A that we didn't already list right here? We already have A, E, H, and G. So I can cross that out, A, E, H, and G, and this is what is left over, D, I, and J. So I'm going to list that right here. So remember, we already have above everything that is in set A. Okay, let's do the same thing for B now. We already have here G, E, and H. I'm going to cross those out. Oops, I shouldn't have crossed that one out. Okay, so G, E, and H. So what is left? We have a B and an L, so we'll put that right here. And we will do the same thing for C. We've already have A, E, and H here. A, E, and H. The last one we need to put into C is C itself. So the last thing we need to do is look at what is in U only. So let's do that. We'll cross out any of the letters that we have already in the Venn diagram off of U. So we've already got A, we have E, we have H, we have G, C, B, L, D, I, J. And the last two that are there that we haven't got anywhere in the Venn diagram are F and K. So we're going to put those on the outside. So I want you to try this on your own, and then, so pause the video and then come back and see if you got the correct answer. So look at my Venn diagram and see if this is what you got. Take a moment, pause it again, and check your work. The next topic is to prove equality of sets. And what we're going to do is remember that we're going to use the regions that we have listed here. We have 1, 2, 3, and 4 to help us prove that the left side is equal to the right side. So the first thing I want to do here is find out what A intersect B is and what region that is. Well, really A intersect B is Roman numeral 2. And what is not Roman numeral 2? Well, that's going to be 1, 3, and 4. So I'm going to list that right here. So 1 plus 3 plus 4. That will be the left side of my equation. On the right side, I need to have A naught union with B naught. So let's find first what A naught is. That's going to be regions 3 and 4. And B naught is going to be regions 1 and 4. So if I were to put those two things together, because it's a union, it really is 1 plus 3 plus 4. And as you can see, the left side equals the right side. So the complement of A intersect B does indeed equal the complement of A union with the complement of B. That brings us to De Morgan's law. A lot of times in algebra, we like to do the distribution of something. So say we have 3 times x plus 3. We like to distribute the 3 to both sets, which would make 3x plus 9. Well, we want to do that in this case too, because we have this prime here that says a complement. So it makes sense that we would go to the inside and prime both A and B. But if you'll notice that the intersect becomes a union instead in both cases. So make sure if you're going to distribute the complement sign or the not sign, that you change the intersect to a union sign. And that same way it goes here. It's a union and it becomes an intersect sign. This last one, we are going to look at proving the equality with 3 sets. So let's look at part A first. It says which regions are represented by A intersect of B union C. Well, let's first look at B union C, and that's going to be everything inside of this area here. So we are going to put down 2, 3, 5, 6, 4, and 7. And we want to know what A has in common with these. So if we look at A, we know that A also has 1, 2, 4, that's a 4, and 5. So what do these two sets have in common? I see a 2 here in both sets. I see a 4 in both sets and a 5 in both sets. So I can say that this is equal to 2 plus 4 plus 5. On part B, it's wanting to know what is the union of A intersect B union with A intersect C. So remember that A intersect B is this region right here. So I'm going to write that right underneath the A intersect B. We have 2 plus region 5. A intersect C is this region right here. That is region 4 plus 5. And what is the union between the two of them? Well, we're going to put them all into one pocket. So that would be 2 plus 4 plus 5. Part C says, what do you conclude by looking at A and B? Well, notice that the final answer is that they're equal to each other. So now we can say with certainty that A intersect of B union C is equivalent to A intersect B union with A intersect C. That concludes for today's lesson.